Hi everyone, so where exactly did we leave off? We left off with function transformations. We were looking at things that looked like this. F of b times x plus c, and then we're going to put an a out here, and then a plus d on the outside. Okay, so where you can multiply the input variable by a number, you can add that input variable to another number, or add a number to the input variable. You can multiply the function output by a number, or you can add a number to the function output. Now, something that I went over briefly in class yesterday that I want to just hit on again is that if you have something of this form, so f of ax plus b, the way you want to look at this in terms of graphing is you want to factor it. So you want to make it f of a times x plus b over a. Okay, so what we're doing here is you're taking this a and you're factoring it out, but still inside the function. Okay, so notice this a, if you distribute it back in, would give you just a times x plus b. Okay, so the reason we're doing that is you're doing reverse order of operations here because you're doing the input variable. So instead of multiplying the x by the a first, you want to look at this adding. And remember, what happens when you add to an input variable? You move to the left, not the right. And if you multiply by a, then you're actually reducing by a factor of 1 over a, or you're multiplying by 1 over a, or reducing by a factor of a itself. So it kind of has that opposite effect. So one of the things I wanted to talk about today is how does this apply to everybody's favorite functions, trig functions. Now, we talked briefly about what trig functions were. They're functions that relate the proportion or the ratio of certain sides in a right triangle to the angle formed in its in one of its vertices. But how does that work in terms of graphing? Well, I briefly went over this, so let's draw ourselves a graph. Okay, this is a coordinate axis. Down here we're going to have -1. Down here we're going to have +1. Over here we're going to have 2 times pi. Halfway up the middle we've got pi, 3 pi over 2. Okay, so we've got those values. Now, what is it that I'm actually drawing here? Well, if you remember the unit circle, oh, there the switch just popped. The unit circle, this is if you basically undid the unit circle, cut it right here, and then unrolled it, and then graphed the values of these functions on a scale of 0 to 1. So on a scale of being from here to here, it would look like what I'm about to draw. So just think that we've cut it here, and we're unrolling it that way, because this is 0, and this is pi over 2, and so on. Okay? So let me just undo here. Okay, so what does sine look like? Let's make sine in yellow. Alright, so sine is 0 at 0. It's 1 at pi over 2. It's 0 at pi. It's -1 at 3 pi over 2. And it's 0 at 2 pi. So if we plot this, we're going to get something that looks like that. For cosine, wait, so first, this is sine of theta, where this is theta, and then this is, we could just call this the y-axis. Okay, so if that's sine, what does cosine look like? Well, cosine starts at 1, drops to 0 at pi over 2, then it drops to -1, back to 0, and back to 1. So it's kind of like sine, but shifted by about pi over 2 units to the left. So you may have seen some of those identities back in high school. Maybe not. We're not going to go over those ones. But those are called the cofunction identities that relate sine and cosine in terms of pi over 2s. Okay, so that's sine, cosine. So let me label that. The blue here is cosine of theta. Remember, you have to put a function that it's in terms of. I don't want to see any SINs. So no SIN squared plus COS squared equals 1s. That does not work. That doesn't mean anything. They're functions, so you have to say what they're functions in terms of. Okay, and then the last one's the funny one. The last one is, yes, tangent. So tangent, it doesn't exist wherever cosine is equal to 0, because tangent is equal to cosine, or sine over cosine, or rise over run. So again, starts at 0, shoots up to infinity. Here it starts at 0, goes down to negative infinity on the left, up to negative infinity on the right, and then here, down to negative infinity again. Okay, so these are the basic trig graphs. How would you go about doing the reciprocal functions? This is a really, really good question. What I would recommend you think of is that whenever these functions are equal to 1, the reciprocal function, of course, would also be equal to 1. Same goes for negative 1. But when these functions are equal to 0, then the reciprocal functions are going to be 1 over 0, which doesn't exist, but it gets close to infinity. So wherever these things hit 0, the reciprocal functions are going to be at infinity. Whenever these things hit infinity, like tangent, your reciprocal function is going to go to 0. So you might have a homework question about that. Keep your eyes open. Okay, so these are the functions.